All right, we've done it. We're now on our ninth and final video for this module. We're talking about the mean value theorem. Now, the mean value theorem, this really is the same mean value theorem that we were talking about earlier, and I'll show you. I can actually explain it right now to you. If you look at the mean value theorem, all right, it says that f of c equals 1 over b minus a, the integral from a to b f of x dx. So if you have f of c equals 1 over b minus a, the integral from a to b f of x dx, and then just for grins and giggles, you take the derivative of each side. Well, the derivative of f of c is f prime of c. The 1 over b minus a, that's just a constant, right? And that doesn't do anything. But then when you do the derivative of this guy, right, from the integral of a to b of f of x dx, you get f of b minus f of a. So you're right back to where you started. We're doing the same mean value theorem that we did earlier. Okay, so it's not really a miracle, it's math. So if f is a continuous function on AB, then there exists a number c such that f of c equals 1 over b minus a, the integral from a to b of f of x dx. So this right here, the b minus a, the 1 over b minus a, the integral from a to b of f of x dx, this is the average value of a function. So that's basically taking every value of that function, adding it up, and then dividing by the number it has. All right, so when we say mean value theorem, we're referring to the mean average, that measure of central tendency, if anybody's ever taken statistics. All right, so we're saying the average value of the function has to exist somewhere on the function. All right, somebody has to be average, which is a whole other conversation for statistics. But if you have a continuous function, if you can find the average value of that function, then you can find out where that average value exists. Okay, so I try to do this through a nice physics application for my physics people in the course. There were some great ones for business and for chemistry. I'm not well versed in those, so I would need to do a little bit more research to figure those out. Or if anybody has suggestions, by all means, give them to me, and I'll be more than happy to work it into one of the modules. So we're back to our velocity. I'm using the same function I used before. So v of t equals sine of t minus 2 cosine t. T is measured in meters per second, which means time is measured in seconds. I've changed the interval, though, from 0 to 3 pi over 2. And I'm asking, at what time does the average velocity occur? So what we're going to do is that we're going to say velocity equals average velocity. So our velocity is v of t. I'm going to leave it as v of t for a while until I change it later on in the problem. But now our average velocity is going to be 1 over 3 pi over 2 minus 0, the integral from 0, 3 pi over 2 of, I'm going to use v of t again, dt. Okay, no absolute value bars because we want to know what the average velocity is. So that includes everything above and everything below. Okay, and again, v of t is this function over here. So our velocity, v of t, is going to equal, this simplifies to 2 over 3 pi times, when you do this in the calculator, you get a happy little number called 3. So the 3's cancel out, and you're left with 2 over pi, equaling, so this becomes that. I'm going to swap out v of t now. So v of t is going to equal sine of t minus 2 cosine of t. All right. I'm not going to bother solving this algebraically. All right. I went to my calculator and I graphed it so that I had my one curve like this, and then I had my line 2 over pi, and I found out where they intersected. Yeah, so they intersect at t equals 1.396 and t equals 3.960 in our interval. I don't think this one's in the interval. 3 divided by pi, 3 pi divided by, oops. Oh no, it is in the interval. Yep, we're all good. So these two values here are within our interval. So these are the two times when it's actually going the average velocity. So 2 over pi is the average velocity. And these are the times when it's going when the particle is actually traveling the average velocity. Okay. So that basically sums up module 5 here. It was a lot. There were a lot of videos here, but I tried to make them all more or less short and sweet and to the point. So just to bring you all back to the beginning of it, we did a lot. Where am I here? Sorry. I don't have editing equipment, otherwise I would take care of it myself. So here we are. So we did rectangular approximation methods. Within the rectangular approximation methods, we had a left, a right, and a midpoint. Okay. Then we did Riemann sums. I showed you how to do this in the calculator. All right. And how basically you're finding the sum of an infinite number of infinitely small rectangles and coming out with a number, which is a really cool thing. We did the fundamental theorem of calculus. There's two parts to this, part 1 and part 2. We talked about it in this module. We'll be applying it again in the next one. We did the rules of integration, the table of these, and I worked some out by hand for you. Then we did integration by substitution, so this is what I called U substitution. This is important because it absolves us from having to know a quotient rule and a product rule and a chain rule. That one rule takes care of everything for us. Then we talked about some applications of the definite integral, which was kind of a nice review going back to the fundamental theorem of calculus. And now it's not on this, but it is in your notes. Number 7 that we did is the mean value theorem again. And the mean value theorem is just something that couldn't be left out. And it connects to the fundamental theorem of calculus and does a lot of things for us as well. Some of them being, you can find out where the average value occurs, or if you're just interested, you can find the average value of a function. And that, can be used all over the place, be it business and economics, physics, chemistry. If you can plot a function for something, you can find the average value of it using the mean value theorem. All right, so that does it for module 5. After this one more module, and we're done with the course. So, as always, if you have any questions, I am in office hours, or you can email me at any time. Thank you.